All right, we're moving from the textbook that we've used so far in the course to another textbook that we'll use for the last 4 sections. Now, in this second part, notice we're starting on topic 2.3. So that indicates we didn't do 2.1 and 2.2, which gives some background on sets. So what I'm going to do is give you a little bit of background so we can move forward. Now, what is a set? By definition, a set is a collection of objects. And in a math class, we might often think it's a collection of numbers. So you may or may not recall from way back in the beginning, we talked about sets of numbers. The first set were the natural numbers, then we went to whole numbers, and then the one we featured way back in section 1.8 was integers. And then we have rational and irrational numbers, and then the set of real numbers that we use basically in this course. Now, when we talk about sets, we use often what is called a Venn diagram to show sets, illustrate sets. Now, it's with a capital V because it's a name of a man who developed this diagram. That was Mr. Venn. Okay, so we usually have a rectangular box and then circles inside. Now, as we look at this, the box represents what we call the universe. And we usually use the letter, capital letter U, to indicate the universe. This would be all of the members of the set that we're thinking of. And then inside the universe, we would have a particular set. And often this set we could call set A. And we would define set A. Let's give an example. So in the universe we have 1, 2, 3, 4, 5. So these would be the elements of the set, or the universe. Now, we're saying in set A, we have the elements 1, 2, 3. So of the universe, set A only contains some of the elements. Now, as we go to the next slide, we see the universe now has 2 sets, a set A and a set B. Now, in set A, it has the elements 1 and 2 of the universe, and set B has 3 and 4 of the universe. So these sets are not connected. And sometimes when we see something like this, we say the sets show disjoint. They're disjointed. They're not connected together. So again, we're doing some background information. Now, in this next one, what we're seeing here is, again, we have the universe. The elements of the universe are 1, 2, 3, 4, 5. And we're saying set A now contains elements 1, 2, and 3, and set B contains elements 3, 4, and 5. And as you look at it, you see, oh, wait a minute, set or element 3 is found in set A. It's also found in set B. So we illustrate that in a Venn diagram as an intersection. Now here the sets are jointed somewhat, and there is an intersection. Now, as we start topic 3, and we're into it a little bit here, the symbol that we use for intersection, and we'll be going over this again, is sort of an upside down U. This indicates intersection, and a word associated with this is a very important word in mathematics, is and. Now, another word that we'll be looking at shortly, this is background and what we're going to be doing, is union. Now, for union, the symbol is sort of like a U, but without the line here, just this part. And the key word for union is the word or. Now, if we wanted to show intersection of set A and B, we would often do so by coloring in this part. This is the intersection. If we wanted to show union of set A and B, we would color the whole thing in. So this is some background, and now we'll move on to our regular PowerPoint series. Now remember, this topic is operations with sets. So we'll take a look now at some of these operations here. We use Venn diagrams to solve or do these operations. When some, but not all, of the elements of one set are contained in the other, the sets are represented as an overlapping circles in Venn diagrams. Now we already showed this. Do you recognize it? Elements that are common to two sets are referred to as an intersection of these sets. Now, here is the formal definition of the intersection of two sets. So you want to take some notes on this. We say the intersection of set A and B is the set of all elements, these are members of the set, common to both A and B. And we denote this intersection of A and B as this symbol here. A intersects with B. This is the symbol we use for it. Now in set builder notation, we're saying that X, and you could write this down, is such that X are elements of A, that would be set A, and, notice the word and, that's the word that is associated with intersection, and X contains the elements of set B. Now, again, one of the things we failed to mention, this symbol here, which looks like a kind of a C with a line there, this is the symbol for an element. Okay? Now, again, this was in an earlier lesson we didn't cover, so you need to add that so you know what we're talking about. Now, as we look at the example 1, and write this in your notes, example 1, determining the intersection of sets, and you want to write this out as well. You want to see or develop a strategy for getting the answer. So, something you might do as a strategy is to look at the letter N in set A. Is it in set B? No. So then you look at U. Is it in set B? Yes. So you might put like a little underline there. M? No. B? No. E? Yes, E is there. R? Yes, R is there. S? No. So, in writing your answer, it would be A, set A, intersects with set B. And then in writing set notation here, we use what is called roster or listing notation. We just list them, and alphabetically is good. So we have E, R, U. And notice it's the proper U. Now, usually members of the set are lowercase letters, and the set itself are capital letters. All right, let's look at what the book has as they give us their answer here. Now, notice they're listing it nicely. A intersects with B. They're listing the elements of A using the symbol for intersection, and then the elements of set B. And as we showed, they're not listing it alphabetically. Again, the order in sets is not significant. Now, in a nice Venn diagram done by the authors, here's what it would look like. So the elements here are only in set A, but the intersection, which is shaded, and then the elements that's only in set B is the L. So again, this is rather the simple example. We're going to get to some that are much more challenging. But again, you want a strategy to get to the answers. Now notice in the word numbers, there may have been something repeated. You only list it once in your Venn diagram. Now in example 2, you want to write that down. We want to use a Venn diagram to find the intersection. So here, this is a Venn diagram representing students that went on a spring break trip. And some went skiing, some went hiking, and some did both. So by looking at the Venn diagram, can you pick out those who went skiing and hiking? You might say, well, this one's an obvious one. Because, let's go back here. The part, not too far back, the part that is shaded, and the use of a Venn diagram shows, in this case, intersection. So there is our 13. And then they're laying it out for us nicely. Okay, now we did mention this briefly in our introduction. That is the word union. As a little quiz, what is the symbol for union? Well, it's this sort of a U-shaped figure without the other part of the U. And what does it mean by definition? Well, X is such that X are elements of A. Now notice the word, or is the union word. Sounds like a quiz question for me. And X are elements of B. Now, let's do these. And we're going to look at them. You need to take time to write them down. And again, using what we've mentioned already. Here we want to show union between A and B, union between A and C, and then union between B and C. Now, again, you want a strategy for doing this. So, again, you can copy it down, and then we'll get on to a strategy. So, for letter A here, union between A and B, where you're going to have all of these and all of these, and you don't repeat. So we need a 1. We need a 2, 3, we need a 4, we have a 5, so 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, now we need a 6, and we need an 8. Now, union between A and C. Well, again, a shortcut is we know we have 1 through 5 here, so 1, 2, 3, 4, 5. And then now we have 7 and 9. Now, I recall one time when I was on a roll and putting these values into our software program, that I put a comma here. And of course, there's no comma there, so they counted it wrong. But again, for something like this on your test, I would give you full credit. That's just a little typo. Now for B and C. Now, we have a 1. We have a 2, 3, 4, 5, 6, 7, 8, and we have a 9. And you can check your work, of course. Again, you're developing a strategy, and these are still rather easy. They are union, and the symbol is this. If something is repeated, you only list it once. The formal way to write it, of course, is this. A union with B lists the elements of A, the union symbol, and then bring them all together. Now, notice there are some that would also be intersection, but everything is included, and items are not repeated. Now, if they asked us for intersection of A and B, we would then go and say, look, there's a 2 and there's a 4 in both. But originally that's not what they asked. They're just illustrating that. And then this is done in a similar manner. And again, there is intersection. They're not asking for it here, but they may illustrate it. Yep. And again, some things rather easy. This is how you should list it in your homework log and in your notes. Now, notice what we have here. Here, these are even integers. These are odd integers. So there is no intersection because there are no elements in common between the two sets. Now again, a new item they're introducing here, and I want you to take note of this, is when they're asking, let's say, B, set B, intersecting with set C. And you see there are no elements that intersect. There are no elements common to both sets. We say there's two ways to write it. One way is we write the braces but with nothing in it. This is an empty set. Or the other way to write it is a 0 with a slash through it. That is, there are no elements. Now remember, it's not a 0, because then you're saying that 0 is a common element. There are no zeros here. So this is the symbol. Actually, it's probably the letter O as opposed to a 0. O with a slash through it is the symbol for an empty set. Now, the previous examples were rather basic and somewhat easy. Now we get into the more challenging ones, and we're looking for strategy to do them. Well, first is to understand what they're asking. So in example 4, we're combining intersection. Remember, that is a and the union, which is an or. So our universe, by definition, are the letters of the alphabet. And they're showing this in roster notation, indicating that, the full alphabet is there. Then set M is going to be the letters in the word math. N, the letters in the word money. And set K, the letters in the word investor. Now, we have to understand what they're asking us. They want us to show union between math here, the M set, and then we have to find the intersection of N set money and K set investors. So the question is, what do you do first? Well, according to the order of operations, you're going to do what's in the parentheses first. So this part shouldn't be too difficult. You're just going to see what letters intersect between set N and set K. And you can do that by underlining them or whatever technique you're going to use. Now, once you determine what that set is, you just bring it to union with set M, the letters in the word math. Now, I could write this out, but they do a nice job here, so let's just follow. Remember, you do what's in parentheses first. You're going to do the intersection. So, intersection. They've written it all out, which is nice, a nice way to do it. This way you can start underlining or whatever technique. Operations in parentheses first. So, from this, the intersection of letters are the letters O and E. So now we've done this part. It's O and E. So we just have to put it in union with all of the letters in math. There's math. There's 1. And there's our final answer. Now, these take time. You'll have to pause the tape, of course. You'll have to write these out. You want to understand what's going on. It's not too difficult as long as you know what's being written there and a procedure to get the answer. All right, now we do B the same way. And again, you might try this on your own. You have the information, and then check to see if you are getting it right. So in this case, we're now going to have union between set N and set K, which gives us this list, and then we're going to have intersection with the words or the letters in math, and our answer is just this. So we'll pause here at this time. In fact, we're going to take a big pause because this will be the end of part 1. We'll then go on to part 2. These lessons are rather extensive and kind of comprehensive.